Hello, everyone. Today, I want to talk to you about building enterprise-grade AI apps with Snowflake Native Apps and Snowpark Container Services. In this presentation, I'm Eduardo Laureano. I'm a product manager working on our Snowflake application platform, and I'm honored to be joined by Hema, who is the head of engineering and co-founder at Kumo AI, to talk about what they've built in our platform. Let's get started. For this next 30 minutes, what I want to cover is just give you a brief overview on the native apps framework with Snowpark Container Services. I want to highlight what's new, cover some of the core concepts that you see when you're using our product, but then really demo it. Really want you to leave here with knowing how you can get started, how you can start building apps. But beyond my demo, you're going to see a real enterprise app in action with Kumo. We're going to go through an overview of the AI challenges and what they were able to achieve at Snowflake. And at the end, I want to give you a glimpse what's in the future for our application platform. So jumping right in, I want to highlight what we do with Snowflake Native Apps in general. Snowflake Native Apps allows providers in the platform to bring their data and their code to their customers in an isolated way where these customers can trust the platform with those applications running completely isolated in their environment. What we've done with this integration with Snowpark Container Services was the ability for a provider to express much richer logic, essentially anything that can be packaged in a container to be part of their application. Those containers get packaged and through the Snowflake marketplace, consumers can get those applications and install in their accounts. Those containers define services which are materialized into compute pools. And we have a wide variety of types of compute pools that you can use with Snowpark Container Services. And a lot of this will make a lot more sense as I show it to you how this is expressed in the application itself. Now, imagine you want to start, you want to build your application. How do you go about it? So, as you normally would, you're typically going to write your application logic. You can pick your language and runtime of choice. And for the apps that are going to run Snowflake, you might want to add the integration to Snowflake. Maybe you're using dynamic tables or hybrid tables. You're going to configure your log, your event sharing. And if you're monetizing the platform, you can add the billable events too. Once that's all done, you package your containers up, you upload to the container registry within Snowflake, specify how your services are going to be accessed, and finally, you're going to build that into a native app. That's where you're going to configure your application package, which has the steps that you can see below. Once that's all done, you submit your app for distribution to an external consumer, and that kicks off our security review to ensure the application is safe for Snowflake customers to trust our platform with applications in the marketplace. Finally, once it passes security review, it's available in the marketplace for any Snowflake customer to start using your app. I want to show all of that to you in a demo. So the first part of the demo is, I was mentioning briefly the application package in the native apps framework. Now, this application package, the main file that defines what's in it is the manifest file. And here you see the manifest.yaml. It lists all the artifacts, which are essentially all the files that compose your native application. The README file essentially describes your app, and this will be rendered in the Snow site UI for people that are obtaining your app. It has a setup script, and that script is going to be used upon application install as well as upgrades. And because now we have the power of container services, you can define any number of images that your application uses. This application that we're going to show to you today, it's a simple application with a single image, but you could have multiple images, one for the front end, one for the middle tier, one for your back end. Now, very important, the application for it to work, it needs unique resources that are very powerful. We're going to run in the consumer account. So it will need the ability to manage a compute pool, to create them and to scale. So for that, it needs the create compute pool privilege. This application that we have here has also an endpoint that people can access it from a browser. It could be an API. So for that, you need this other privileged bind service endpoint. So that's all the components of the manifest. Now let's take a look at how you get it set up. So this here essentially creates an application role that's going to be creating the consumer account that's going to use this app. And we're going to create in this separate script, we're going to create some procedures that we need. First, we have one to create the service. That compute pool that I talked about, here's where you specify the actual creation of it. You're going to determine the amount of nodes it needs to run, minimum and max. You could configure auto suspension rules, auto scale, and the type of compute. And that's very important. We'll have CPU, high memory CPU, and GPUs all available for you to use in your applications. Finally, we create the service in that specific compute pool, and the service is defined in its own spec YAML file. Let's take a look at that. Spec YAML determine the service that runs there. It points to the exact image that has the code that got packaged with Docker for your service and the endpoints and which port in which they run. Now, aside from it, the actual application we have is pretty simple. The main functionality I want to show you, it's just an echo functionality. So you're going to pass some input and we're going to print that input back into the console. So you see that echo function in here as well. The rest what I have here is just clean up and resume. So this demo can be run multiple times. Now, let's get this is all in my local machine. Let's get that all up and uploaded to Snowflake. So in our Snow CLI, we have a real nice command that abstracts a lot of it from us. So we have this command called Snow App Run that essentially creates an application object based on all those files we just looked at. So nicely wrap all of them and uploads to my account. I already had authenticated to my account, so it just needed to upload it. And you can see once it's done, you can see the actual URL that you have for the application we just created. Let's take a look at this application. All right, this is the app we just created. So you can visualize it now in our Snow site, which is our UI that you're going to do everything Snowflake at. So there is a section just for apps. In that section for apps, we can see the app that we just created. Now, all those privileges that we requested are right here for the consumer to grant those privileges. We're going to continue on the command line, but just we can see that the app is now real. Now let's start by granting those privileges. I think that's the first step for this app to be able to run. We created those privileges. The next step for us here is to actually create the service. Remember, I showed a procedure that creates the service, so we're gonna kick that off here. All right, the create service command is now running. It needs to provision that compute pool and then create the service. I want to go back and talk a little bit about the app that actually we're deploying. So I mentioned you can deploy anything that you can package as a container. So here we have two parts that I want to show. First, we have essentially a Python web service here, receives gets and posts. The get path pretty much spits out HTML. There's an index HTML. I'm going to show that to you in a second. And if you do a post, that's where our echo service is going to work. So it reads the input and spits the output back out in the console. That's essentially the main logic I want to show it to you here. Now, there are a lot that we can do here. We could do HTML. So I added just a little bit of JavaScript so you can see. So it's a very simple, just simple starter code. It's a tic-tac-toe game, so for you to play the game, but just shows that you can deploy anything. You could deploy a JavaScript framework, you deploy React, Vue, Angular, you name it. But this is something simple for you to see it working. Let's go back to our service now. Now let's check what's the status of our service endpoint. And the service endpoint is being created because the creation of the compute pool is still happening as an instantiation of the endpoint. All right, now let's check on the status of our service. The service is now ready. So it's fully instantiated, our container is running with both our JavaScript as well as our Echo service. First, let's test it out, the Echo service that we created to ensure it's working. So it spits back out the exact string that that was issued to the Echo service just to show that it actually works. I'm going to change the string real quick, and it works as expected. Now, another thing that's cool is we can see the service endpoints, right, that we defined. So let's take a look at the service endpoints. So here's show endpoints to show any ingress URL related to this app. Let's put that in the browser. Right, let me just clean up the bad formatting here, and we should be able to see our endpoint. It's all ingress endpoint are authenticated, which is nice. I'm gonna enter my credentials real quick, and here you go, just a simple tic-tac-toe game. Uh, it works, and you could restart just to show that you could have some JavaScript. But this is a very simple JavaScript. I encourage you to look at some of our more advanced examples. We have one here, which is great, which shows React and Cortex all working together and renders a nice UI at the end. We also have 3-tier apps examples in our native app sample on GitHub. So a lot of apps that you could use. And I want to flip back over to our app on Snow site. Now this app is running. The privileges have been granted. If we were working Snowflake data, it would show here exactly which data the app has permission to work with. Here you can go to the logs, so you can do your observability, you can see your traces, and all your telemetry are going to be available right there. You can then share events back with the provider, and you can see that our compute pools are running in this application. So, oh, great, I want to go back to the slides to talk about some additional features that we have. So, you've seen a lot that's new with our integration. Everything on the left, I was able to show it to you. And on the right, some of the things I didn't cover, but we also have block storage working as SPCS that can work in your app. If your app spends credits Snowflake, you can set up spending limits and be monitored as you're approaching a certain budget. Your specs can be created to dynamic information with spec templating, and your containers can access external sources with external access integration. A lot's possible for you to do. And I'm very pleased to announce that everything you've seen is now generally available for you to use for production use case on AWS, also publicly available on Azure. And with that, I want to now show a real enterprise application solving problems for Snowflake customers using AI. With that, I have Hema to talk about what Kumo did with native apps.
Hi, thank you, Eduardo. I'm Hema Raghavan and I head engineering. I'm also a co-founder of a startup called Kumo AI. And in this part of the presentation, I'll tell you how Snowflake through Snowpark Container Services and native apps has given a startup. We're just a 25-person engineering team. It's given us the flywheels to build what we wanted to, bring to the world, which is the transformer revolution for data warehouses. It lets us focus on that, and it's given us the flywheels to bring our product to consumers. So to understand what we're building, I just want to, paint the landscape of AI. We're all familiar with the generative AI revolution that has been transforming how we do summarization, chatbots, and so on and so forth. But there's a whole world of predictive AI applications with personalization, next best action, churn, lifetime value, and use cases of that form. They're often on private data, and usually a data scientist here is tasked with improving a model like an ad CTR model, a personalization model, to bring direct value to the business. Often this data is on relational data, right? So you have data like in Snowflake, and it's laid out in different tables with primary key and foreign key relationships. When we set out to build Kumo, we wanted to bring the transformer revolution to workloads in that predictive AI landscape. So when we started focusing on how do we make our data scientists productive, the founding team at Como was all about we're all ex-data scientists trying to drive efficiency, and how do we make a data scientist, and we're going to call her Sally for the purpose of this presentation. And let's say Sally works at a company like H&M, and she has to build she's getting pulled in many different directions and being asked to build models for churn, lifetime value, or recommender systems, and all of which are directly connected to business impact, right? So how do we enable someone like Sally to use the latest model architectures is what we wanted to solve. So I'm going to go deeper into what Kumo is. I'm going to go into a demo, and through that, I'll be peeling the layers and actually showing you what a complex app Kumo is. We use a lot of the features that Eduardo just talked about, and even more. So it's been a great partnership. I'm going to go into talking about Kumo, but at each step here, there's a lot of technology under the hood that we have built but are easier to deploy because of Snowpark container services. And I'll show you some. So the first thing is Kumo is an application that is trying to bring the AI revolution to data warehouses. We enable that through letting the data scientist configure a connector into the Snowflake data warehouse. Now, here's another feature that security teams love, because we don't, or the organization, in this case, Sally's organization, doesn't have to grant access to all tables, either to Sally or to Kumo. So this is a great example of the kind of AI governance that security teams want bringing in AI into their organizations today. So the IT or security team can actually go in and say, here's the app name, and here's a warehouse that we want to give it access to, as well as this is a database and a corresponding schema, and whether we want to give it access to all tables, views, etc. You would just go and run the short script to give it access. Then Kumo, when you're configuring the connector, has to set the corresponding database, warehouse, and schema that it just got privileges to. I have a connector set up, and what happens next is Kumo allows you to start connecting tables now that it has access through the connector. So you have the connector that we just set up, and I can browse all the tables that were set up through that connector. And let's say I want to import the articles table. And we said Sally, in this case, the data set is of articles, customers, and transactions that they've had in the over a 2-year period. And this is the table that contains the product information. So the app, on the app side, we actually allow data manipulations to happen that a data scientist might typically want. This can include simple data type transformations. We also prefer to have annotations on primary keys and so on. So you can, mark a column as a primary key column. And then you can also bring in things like embeddings. Like here's a text column, but you could also call Cortex and actually transform that into an embedding. So in this way, you can bring very rich tables into Kumo through Snowflake. Now, the key part about Kumo, as I mentioned, is this technology called graph neural networks. And this is where I'm going to spend maybe some more time of this demo. We imported the tables, And the idea for Kumo would be to, create a graph. Let's just call this a demo graph. And we import 3 tables that I already brought in those tables earlier. And Kumo infers the link structure. We already know the primary keys that the users has annotated it, but Snowflake also has good metadata. So sometimes we can actually directly do inference. And we determine the primary key foreign key relationship of under the hood. Users can also change the link structure because many times data is very messy. At this point, we have enough information to start creating a graph to enable a graph neural network. So the next thing I do is I'll say complete graph creation. And on this graph, I can do some inspection on the graph, and it says, hey, you have, some messy data, not 100% overlap between your primary keys and foreign keys. But as a data scientist, I may know that that's normal and I'm not alarmed by it. So I'm going to ignore those warnings for now. Another key value proposition of Kumo is this very rich and powerful language that we've created called predictive query language. What Kumo does is it allows you to write these queries which let you describe any business problem in this very expressive language called PQL. So in this case, Sally wants to build a churn prediction model. So she says, hey, in my data set, and I've done all this analysis on Snowflake before, in my worksheet, I found that usually the behavior over the previous 60 days is very indicative of whether a customer is going to churn on the next 90 days. And so she constructs a query like this. The PQL language is very rich and actually enables a whole range of problems from forecasting to recommender systems and so on. Kumo automatically reads this query and says, hey, this is a binary classification problem. We go next. And then Kumo says, emits a model plan. And the model plan is very deep. So depending on the data scientist and depending on how deep they want to go and manipulate the graph neural network parameters, will let you do that. And this is what the data scientist really wants to spend time on, building models and playing where the juice is and to drive value for their companies. So Sally says the default model plan looks great. I'm going to go with run mode fast, and I do a save and train. At this point, what Kumo does is it takes all of those 3 tables. This is a very simple example, 3 tables. We have customers running it with, dozens of tables. It takes those 3 tables, it starts using those primary key, foreign key relationships to create a graph structure. We then, in this very highly optimized graph structure, and we use Snowpark to actually build that graph structure and store it on disk using the highly performant block storage that Snowflake has created. We store it on disk, and then we're spinning a farm of GPU and CPU compute in order to run graph neural networks. This typically takes about 15 minutes to run. So I have an example query that I have already run. And when it finishes, Sally can go, she can say, hey, I have a pretty good model. It looks like even on 2 runs, it's achieved a pretty good model performance. I can do evaluations. I can verify my training table statistics. I can, and Kumo has the notion of a model explorer, which even tells her which columns and tables are the most relevant. And very intuitively for churn prediction, the transactions table is the most predictive. But of course, data in other tables are also relevant, like the articles table, and interestingly enough, here the customers table is not as relevant. So under the hood, what happened here was Kumo defined a heterogeneous graph based on relational tables. We used Snowpark to create this rich graph representation on these tables. And then we automatically annotated labels for whether a user was going to churn or be active with this predictive problem. The training part, which a user could manipulate or it could be choose not to manipulate, actually ran graph neural networks. You can think of graph neural networks as a transformer technology for your relational data warehouses. To make all of this happen, this is not a simple app. It has a front end that uses CPUs. It has a back end, which is composed of both CPUs and GPUs. This mixed compute pool is necessary to keep costs at a minimum for our customers. And we use the high IOPS block storage to store those intermediate graph representations. And this architecture of ours is letting us scale to graph sizes of over 2 terabytes in size with over 30 billion edges. With that, I'll hand it back to Eduardo.
It's fantastic to see such a rich application in our platform. Here, I want to give you just a quick glimpse of what has been built and what's coming. And we're going to build even more in terms of cost-efficient compute options with multi-tenancy, managed services, more ability on the UX framework, and make it even easier for you to add data for an app to manage with restricted college rights. With that, I want to really thank you and hope you try the product and let us know of any feedback.